Now, I am glad to invite Shri Professor C.K. Raju for his talk. Thank you, everyone.
Thank you, madam.
Thank you. I suppose this time I can start for real. I'm sorry I started early. All right. So as I said, these lectures are all right, but eventually one needs to run courses. But without that, it's not going to work. You just keep talking, and that will be now. What is the issue? All right. So are you able to see the screen?
Yes, sir.
Okay. So
Yes, sir.
I want to talk about 3 undergraduate level courses. One of these courses has been tried out also at the postgraduate level, but I will leave that out because that's too complicated. So the 3 courses are calculus and obviously differential equations, statistics, and history and philosophy of science. All right, these are 3 courses that I want to talk about, and I will try to cover it in whatever, say about 45-50 minutes, 1 hour, and let's hope that there will be ample time for questions. All right, so these 3 courses that I want to talk about, they all have Indian origins. So calculus is of Indian origin, and as is probability and statistics. And I think that a corrected history and philosophy of science needs to be taught so that students are aware of the historical Indian contributions to mathematics and science. All right, so what are the details? You need to do some background reading. I had sent something, but I suppose, so for example, about calculus, there is my book, Cultural Foundations of Mathematics. And this is by Pearson Longman. And if you see, the subtitle of the book is, it's the nature of mathematical proof. So it's a philosophical issue. And the transmission of calculus from India to Europe in the 16th century CE, Christian era. The other thing is that there is this article on probability in ancient India. So you can see this article. It is available online at this link. And it is in the Handbook of Philosophy of Statistics by Elsevier. It was published around 2011 or 2012, something like that. The third thing that I want to talk about, history and philosophy of science, there is a booklet called Is Science Western in Origin? And this was published by the Multiversity, and it is edited by Vinay Lal of the University of California at Los Angeles, historian from there. As you see, these people who are hanging upside down, one of them is Newton, one is Copernicus, one is Euclid, and this is Ptolemy. So the idea is to put most of these things upside down. That is how the artist has visualized it, and that's quite an interesting way of visualizing things. All right, so these are 3 courses that I would like to talk about, and there is plenty of background reading. This Cultural Foundations book is 500 pages, article on probability in ancient India, and this booklet. Now, the second part is, why do we want to teach these courses? And I would like to emphasize that we want to teach these courses for their practical value today. We are not teaching Indic knowledge courses just, well, at least I am not teaching just for their sentimental value, right? Just because our ancestors did it. Ancestors may have done many things. Some may be right, some may be wrong. We accept some things and go forward, and we may need to reject other things. So we are not doing it just because our ancestors did it. We are doing it, at least I am doing it, for I teach these courses for their practical value to students today. Contemporary value, right? That's my objective, and that's what I would like to do. And therefore, of course, you have to explain what is wrong with existing courses on calculus and statistics. That I will try to explain. I'm just giving a brief summary that they teach only the mechanical application of certain formulae, integration, differential, differentiation formulae for elementary functions. Very limited. A free piece of software can do that much better. And students don't have basic conceptual grasp of the most basic concepts. I will try to demonstrate. Such as what is a limit, what is a derivative, what is an integral, what is probability. They don't know any of these things. If you ask them 2 questions, they are unable to go beyond that. I will demonstrate, go into some details shortly. So I want to teach them on the ganit method. So what is this ganit method and why are we teaching it? First of all, ganit makes math easy. All right. Most people find mathematics difficult. Ganit makes it easy, makes statistics also very easy. Number 1. Number 2, it enables students to solve harder problems which are not covered in current undergraduate calculus courses. Okay. And the third point is that students will acquire a very solid conceptual grasp. So these are 3 immediate advantages, and that is why we want to teach. Not just because it was developed in India, but because it is better. All right. Okay, I would like to drive this point home. These courses were developed and taught in Malaysia, Iran, etc. outside this country first over the last 10 years. And why did they do that? Why did they want to teach it? For their practical advantage, not for their Indic origins. Many Malaysians, have a very poor opinion of India because Indians first went there as indentured laborers. They're very poor. So they accepted these courses solely for their practical advantage, not Indic origin. So let me show you one of the newspapers there, big newspaper, which got this 2-page thing on mathematics made easy. And when I was teaching there, it ran this course on mathematics, no problem. Right? So their concern is that it makes mathematics easy, makes it easy to learn and to do harder problems. All right. So calculus, statistics, we understand their practical value. What about history and philosophy of science? Is it only about our pride? So, to an extent, yes, that Western education has taught us that everything Deshi is inferior and everything Videshi is superior. And hence, see, we don't be, I'm saying we need to be critical. We have uncritically accepted our inferiority. And hence it has taught us to imitate the West in every way possible. And that is very damaging. And this is what our school maths text still teaches in class 9. Maybe you can take a look at it. I will get back to it. This is class 9, chapter on Euclidean geometry. So you see what it says. It says that, in India, in Babylonians and Egyptians, they did very little to develop the subject systematically. And the Greeks, only the Greeks could do it. And that is explained in this thing. And the same statement is made about India. I'm not able to locate it right now, but you can read up the book and locate it. It's 9th standard text by NCERT, which is available online. So this is what we teach in our schools in the presence of this government for the last 7 years. That what we did in mathematics was inferior, what Greeks did was superior. Now it's all false history, that's a secondary matter. But this is what we teach. That this is inferior, that is superior. And that's a very important thing, that we believed it all without checking. We accepted the claim of Western superiority without checking it, and NCERT refuses to check it. They say you have no idea, you cannot check it. So what is the point? Teaching Western superiority at an early age indoctrinates us, and then we believe it for all time. So the consequence is that our academic system 100% imitates the West. So the point is that we imitate the West, and we 100% imitate the West without thinking whether it is good or bad. And that is very damaging. And to the contrary, we are very frightened of not imitating the West. If we do this, what will happen? Something terrible will happen, some catastrophe will happen. If we don't copy, how will our rockets run? How will our bridges be built? As a matter of fact, we taught most mathematics to the West, and they gave it back with some superficial covering and some false history, and we just accepted that. So the main point is we need to be critical. We should not become intellectual slaves of the West. All right? And we should not become superstitious that not imitating the West may result in some terrible catastrophe. That is superstition. We need to check it. So that's what I'm going to show. So this course on history and philosophy of science, it teaches that a claim of Western superiority is bogus. And there was a big debate on it in Malaysia. The editorial that was written by The Sun, which talked about all that I had done, but there is not enough debate, I'm sorry to say, in this country. It's very difficult. So you can read this up. This is archived on my site at ckraju.net/press. And there was a debate which went on for 3 months there in Malaysia. The argument is that this claim of Western superiority is based on a false history and a bad philosophy of math. So we need to check it. All right? And this Purva Paksh that they have said that they are superior, everybody else is inferior, this needs to be contested, openly contested, before we can boast that we did this and did that. We have not done that. This was the Indian tradition. Before you challenge before you talk anything to somebody, you contest the Purva Paksh. Who has contested the Purva Paksh that the calculus as it developed in the West was inferior? I'm saying it. We are unable to do it. Our minds are tied. We're not even able to have a debate on this question. I'm trying for the last 10 years. So there isn't a single university department or decent course in history, philosophy, or science in India. Every Western university has got such a thing. We're not talking about Indic knowledge. Let's have history, philosophy of science proper. Let's know what we did and what we did not do. Let us take credit for what we did. But we do not have such a department. I have been asking for the last 30 years. Nobody is interested. We only want to talk. We were so great. We don't have any facts. That's not how it is done. It requires a lot of effort, lot of work to do history, philosophy, or science, to trace original sources. And it's a very expensive process. We don't want to spend money on it. We just want to boast. That's very bad. So we need to understand the tricks by which a false history was spread, is being spread today through the education system, like the history of Euclid. And the trick of imposing a particular philosophy, people don't understand. They think, what is philosophy? It's useless. But if we change the philosophy, that's what makes us imitate the West. We get into Western hands. I will try to explain that. It's a hard to understand thing, but it's a very important thing. So, for example, when we talk of Pythagoras and we give credit so many times for the Pythagorean theorem, but and say it is there in the Shulba Sutra, I'll come to that, what the issue is. So anyway, the practical advantage of this course is that it will get rid of our sense of inferiority. All right, that's the point. And it will give us the courage to innovate. We say we were great in the past. Let us be great today. Let us criticize and let us innovate. We cannot do that. Then let's stop talking about how great we were. What are we able to do today? That is very important. And what were we able to do before colonialism? If you want to get it back, we need to innovate and we need to criticize what is wrong. All right. So that's the right way to do it. We should not make wild claims that there was spacecraft in ancient India. Those wild claims just turn us into a joke. Nobody takes it seriously outside of India. Even within India, most people don't take it seriously. So they just make us an object of ridicule. Let's avoid that. Or false claims of Vedic mathematics. So Vedic mathematics is not found anywhere in the Veda, and the book on Vedic mathematics accepts this on its first page. It's nothing to do with the Veda. It's just a label that is being used to sell a product. So this is my article in the Hindu on Vedic mathematics, available online, that there is nothing Vedic, that it's not an act of nationalism to replace, because that traditional Indian arithmetic that you're trying to replace is actually coming from us. It's coming from India. What are you trying to replace? You need to be clear about that. So this is the article. There is also a similar article in Hindi that it is not found in any, not in the Veda, not found in any traditional Indian mathematics text. So this article in Jansatta quite a few years ago. So it's not found in any traditional Indian mathematics text from the Vedang Jyotish to the Yukti Bhasha across 3,000 years. There is no mention of it. Why do we need such falsehoods to prove our greatness? We have so many great things, but let's work and get them out. Why do we need to take the weight and corrupt it by making it into a marketing label to sell a product, which is not there? And it has very little practical value. The ability to do mental arithmetic is already mostly useless. Everybody uses a calculator, which is available on the phone, and it is certainly useless for science and engineering or commerce. All right, so let me take a recap, a quick recap, that teaching mathematics, calculus and statistics using the methodology of ganit makes math easy, enables students to solve harder problems not covered in existing calculus courses. And teaching history and philosophy of science explains the false Western history of science used to boost up the West and claim it is superior, plus the trick of using a bad philosophy. It's not just false history, it is a bad philosophy. If you don't put the two together, you will not get anywhere. So we need to escape from the resulting sense of racial and cultural inferiority. All right, so let me start with the calculus. And calculus originated in India with Aryabhatta. It's Aryabhatta, not Aryabhatta, 5th century. It developed across 1,000 years in various parts of the country, and then it was stolen and taken to Europe in the 16th century in connection with the European navigation problem, which was the biggest scientific challenge of the times in Europe from the 15th, up to the 18th century. British Board of Longitude was formed by an act of British Parliament in 1711. Okay, so it was the biggest scientific challenge, and many European governments offered large prizes. I think I already explained this. The big prize offered by the British Board of Longitude, which was given away sometime in 1762. Okay, so they had, because their wealth depended on overseas trade or piracy or whatever, and whatever you're getting back, you need to have good navigation, otherwise all your wealth literally drowns. Just as a side note, it is Aryabhatta, not Aryabhatta. If we don't even know the spellings of our great people, what history are we talking about? What difference does it make? Well, here's another article for that, couple of articles. So Aryabhatta makes, Bhatta is a mixed caste person, is a lower caste person. All right, Aryabhatta, Bhattam is the Padvi, if you like, of a Brahman. It's a common mistake made by people who do not study history of science. They just talk through their heads, they hear something and they talk nonsense. It's also there in Kapila. The Hindi version, if you see, the spelling will be perfectly clear. If you examine, history has to be done from primary sources. If you examine the primary sources, then every volume of Aryabhatiya, it is Aryabhatiya, not Bhattiya. And if they don't know that, they should not be talking about how great we were if they don't even know the spelling of the person. And they change things. Nowhere is it Aryabhatta. Everywhere Aryabhatta. He calls himself Aryabhatta. So what is the significance? I think I explained. Bhatta is a Dalit name. Bhatta is the title of a Brahmin. And what is more interesting, it's not just about this. More interesting thing is that Aryabhatta's followers included the highest caste Nambudri Brahmins from Kerala. Nilakant Somasutwan, who wrote a commentary on the Aryabhatiya Bhashya of Nilakant, which is very important. So caste system was quite different in ancient India. We need to understand that instead of just, playing around games like this, change Bhatta to Bhatta and talk of this and that without studying, without investing any time, just take some story and repeat it. That's not called doing history. Okay, so let's go forward now back to calculus. We say we are falsely taught that calculus was discovered by Newton and Leibniz. It was taken from India in the 16th century, and in the 17th century, Newton and Leibniz discovered it. Of course, they did not claim that, but basically the claim is based on something, a very obnoxious principle called the doctrine of Christian discovery. And the doctrine of Christian discovery, if you see, says that the first Christian to find a land or a piece of knowledge becomes its discoverer. It's an extremely obnoxious doctrine, genocidal doctrine, which was used to kill a whole lot of people. And we need to get rid of it. So this is the meaning of Christian discovery. And that the first Christian becomes its discoverer. And Newton and Leibniz quarreled on that, and Newton called Leibniz the second discoverer. And this is the meaning when you say Vasco da Gama discovered India, Columbus discovered America. There are millions of people staying in both places. What did they discover? We don't have common sense. As a school child, I asked this question. You can take a look at this video. I think I won't go to this, Google C.K. Raju discovery of India, because if I go, they will start running an advertisement. So I won't show you the video, but the link is here, and maybe you can, you can just search for C.K. Raju videos. You should be able to get it. Discovery of India. So it's a discovery doctrine. And we have never studied the history of science, and we are easily fooled. We just believe whatever is told. Most people believe that. And especially if that false history is repeated in math texts, it is repeated in Wikipedia, it's repeated everywhere. So we use check only from these sources, but that's not the way of doing history. We'll come back to this. Let's move on to the calculus. So first thing we see is the size of calculus texts. And they're the same calculus texts which I studied, my children studied, and my grandchildren will perhaps study if we don't change the system. Right? Text of Thomas or Stuart, 1,300 pages. 1,300 pages in large page format and small type with additional things like a CD and so on. So anyway, these are large texts, extremely large texts, running more than 1,000 pages, fat text, difficult to pick up, and in large size. So it takes 3 years to learn the calculus roughly. So if you say study about 1 page per day, that is how long it will take. And it is calculus is taught across 3 years, in 11th standard, 12th standard, and beginning undergraduate courses. But after spending these 3 years, what does the student learn? So the first thing is the difficulty of limits. So student learns very little. Right? Let's look at a very simple calculus statement, d by dx sin x equal to cos x. The student doesn't understand anything. He doesn't know d by dx, he doesn't know sin x, he doesn't know cos x. I will just explain. So if you are doing this, you need a definition of d by dx. You need a definition of sin x. All right? And how do you do that? Defining d by dx requires limits. Limits are not defined. Let's take our NCERT 11th standard text. This is what it says. First of all, we give an intuitive idea of the derivative. Why do you want the derivative if you're talking about intuitive ideas without actually defining it? And then we give some naive definition, study some algebra and so on. Why did this is all supposed to be for rigor? So you start with this, it's indoctrination. You are teaching this is the right way to do things, but you're not teaching what is the way. Students don't understand limits. Okay, the formal definition of limits, well, I suppose there should be plenty of people who know that. If you take a real valued function or one real variable, then it's defined using this limit like this. All right. So this is simple enough, it seems, but you see what is meant by this definition, limit. So if you look up Thomas and Stuart and so on, they will have an epsilon delta definition. I used to teach this. I used to teach real analysis once upon a time, long, long ago in the prehistoric past. So for all epsilon positive, there must exist delta positive such that if x is close to A, then gx will be close to L. Okay. The missing element, you see, both Thomas and Stuart have a section called precise definition of limits, but it is not precise. It's just falsehood to call it precise. Why? Because it's the epsilons and deltas are ritual. They become precise only when you give real numbers. But they don't teach real numbers. All right? And why not? Because there's a difficulty in defining R. Formal reals are often defined using Decolonizing cuts. So you use set theory to build, say, natural numbers, and that's a model for piano arithmetic. And then you extend integers, natural numbers to integers, and then to rational numbers. But then going from rational numbers to real numbers is a bit of a problem. So you construct what are called cuts, Decolonizing cuts. This is the formal definition of a cut. What is it? It is supposed to be a point at which you cut the real line. That's what it's supposed to indicate. I won't go into the formal definition. It is there in front of you, and it is there in any textbook like Rudin or whatever you like to consult. All right. Addition, multiplication, and order are defined in this obvious way. And your set of real numbers supposedly now forms an ordered field. All right. And the issue why they are called cuts, let me explain that a bit. Dedekind's intuitive idea originated from the elements of Euclid 1.1, the very first proposition. It is what is called in India the fish figure. Looks like a fish. Used to draw a perpendicular. So supposing your west and east are, you have a line, and then from the west you take radius and center as west, radius as WE, and draw one arc. And then you take center as east and the same radius and draw another arc. And wherever these arcs intersect, they will intersect at 2 points, and this is used to construct a perpendicular bisector. But what is wrong with this? You see the arcs intersecting. You can build an equilateral triangle according to proposition 1 of the elements. It empirically manifests that the two arcs intersect. But this appeal to empirical methods of proof was rejected in the West. This is the critical issue for formal mathematics. You reject the empirical method. Is that good or is that bad? Your science is based on empirical method. All Indian philosophy is based on the empirical method, except this. So at one stroke, you've rejected everything. And how has it benefited us? Nobody is able to explain, right? So we'll go into that. So R is required for formal proofs, and formal proofs are proofs which prohibit empirical proofs. And empirical proofs are accepted in ganit. Lots of examples, but I'm not going to go into that because right now I'm talking about the courses. I'm not talking about exactly what was done in ganit. That would be done when we teach the course. So the point, please note, if real numbers are essential for calculus, and since Dedekind invented real numbers in the late 19th century, no one prior to that had any proper understanding of calculus. So the claim that Newton did something and so on is completely false. How could they discover something they didn't understand? So these are all these issues, the foolishness of Western history, which makes this kind of a claim. And this is based on my epistemic test. And this is proof. Lack of understanding is proof that the knowledge of calculus was stolen from India. You don't even have to go to all the details, whether they came to, Jesuits came, they had a college, they translated these texts, they took them, what difficulty they had over 100 years trying to understand them, and for another 100 years with Newton's fluxions. Those are all complex issues, very simple issues. If you claim to have knowledge, you should be able to understand it. If you don't understand, you have stolen it. That is what happens, when one student copies from another in an exam, what do? So if you see two identical answers, what I used to do was I used to call the students and check. Does he really have knowledge? If you ask 3, 4 more questions around it, is he able to explain? He is not able to explain. Then his claim to knowledge is false. So according to the epistemic test, that itself is proof that calculus was not invented by Newton and Leibniz because they could not explain what they had done. All right. So I'm just explaining some of the difficulties that occur with limits. Let's go to the other question, calculus about integral, fx dx. What is it? Usually defined as the antiderivative. So if g is the derivative of x, then the integral of g is f plus some constant. And that is unsatisfactory, and it is believed some clarity can be brought out by teaching the Riemann integral. You take a sum and you take a limit of sums. And allow, there's a limit, the partition. As the partition shrinks to the mesh, shrinks to 0, then you will get something like a limit. Big problem. So once more, defining the integral requires limits, hence real numbers, because those limits will exist only in real numbers. If you are smaller, limits may not exist. If you are larger, limits will not exist. Only for the real numbers. And what are the real numbers? They are completely unreal. They are metaphysics. You can't actually construct them. But let's go on. The difficulty in defining functions. So sine of x, what is sine of x? Would somebody like to answer quickly? What is sine of x? How is it defined? Anyone? No, don't want to answer. Okay. So most students think that sine of x relates to triangles. Opposite side of upon hypotenuse is what they will say. And they don't learn the correct definition of sine of x. Since the definition of it's a transcendental function, it involves an infinite series. And if you sum an infinite series, that involves a limit. And they don't know that. See, everybody knows the formula, derivative of e raised to x is e raised to x. What is e raised to x? They don't know because it's an infinite series. What is meant by the sum of an infinite number of terms? They don't know. So this is a problem, and this series is supposed to converge in some sense of uniform convergence, etc. Won't go into that. I'm just explaining there is a problem with limits, and most people don't understand when they write d by dx sin x equal to cos x. They don't know what d by dx, they don't know sin x, and they don't know the corresponding notion of integral. So what the student takes away is calculus texts. What they do is that they trick the students into a sense of into a state of psychological satisfaction of having understood matters. The trick is to make the concepts and rules seem intuitively plausible by appealing to visual intuition, or physical intuition, etc. So what the student takes away is something like this, that the function is a graph, or derivative is slope of the tangent. They can't define a tangent. Let's say slope of tangent. They can't define. I asked this in my pre-test, and not a single person is able to define the tangent. Let's say it touches the curve at one point. Complete nonsense. So I give an example of how a tangent can cut a curve at innumerable points, infinite number of points. Let's say integral is area under the curve. They don't know how the area is defined and so on. So it's a pity, because the belief that intuitive visual intuition may deceive is ironically the basis of the real number system and teaching of limits and so on. So we don't understand. As I gave you the example, Dedekind cuts are motivated by the fact that the fish figure is deceptive. The visual intuition is deceptive. And you go back to that visual intuition, then why do you want all this stuff, real numbers and limits and so on? Okay, now I'm just trying to cover the major problems. The point is that real numbers are not the end of the story. There is a need for set theory, because you can't get right. Dedekind said, I mean, you say Dedekind did real numbers. I mean, whichever way you construct them as Dedekind cuts or equivalence classes of Cauchy sequences, it does not matter. You need set theory. And Cantorian set theory was not good enough. There was only Cantorian set theory in Dedekind's time. He used it and it's not good. You're told about set theory. You're not taught. Nobody even able to define a set. I asked the head of mathematics department in IIT. He could not define a set. And it's the same thing. He said set is a collection of objects. And when I started laughing, he was very hurt. He said, if you had joined IIT, I would have taught you. I said, that's true. And he says, do you think I don't know? I said, well, that is also very clear. What can one do? So anyway, this is the sort of stuff that a student is given. Complete nonsense. This is not a formal mathematics definition. Some Venn diagram just to make it seem intuitively plausible. So there is Russell's paradox. What is wrong with that? You take Russell's class, which is the set of all those x which do not belong to x. So by definition, if R, what happens to R? Does R belong to R? Then you have a contradiction, because by definition, R does not belong to R. On the other hand, if R does not belong to R, then again by definition of R, we must have R belong to R, which is a contradiction. So either way, you have a contradiction. This is just one illustration. There are lots of problems. So paradox is a polite way of saying things. What it means is that any nonsense whatsoever can be derived, because from a contradiction, A and not A, you can prove B according to the mathematical two-valued mathematical logic that is used as the basis of proof in formal mathematics. And that paradox is supposedly resolved by axiomatic set theory, but even among professional mathematicians, they don't learn axiomatic set theory. So you're not just talking of students here. Professional mathematicians, as I mentioned, head of a math department and so on. That's not just the only one. Many others I have met. So most of them make do with this. So now the point is, have you understood the difficulty of existing courses? I can go on like this, lot of material, but how will you understand these problems or further problems like Banach-Tarski paradox and so on? So I want to summarize it by giving you a simple challenge problem. Very simple. That will be, if you try to solve it, then you will understand what are the things that I'm talking about. So what is the problem? It was first used in Cape Town, more recently used in JNU, which is that you prove 1 plus 1 equal to 2 in formal real numbers. Real numbers, not natural numbers, no pianos, axioms, and you prove it axiomatically. Don't say 1 orange and 1 orange is equal to 2 oranges. Yes, I know that. Every child knows that. In real numbers, 1 as a natural number is different from 1 as a real number. If you understand the basics of mathematics, you know that. As I said, there's a Dedekind cut. It's a huge infinite set, or it's an equivalence class of Cauchy sequences. Another huge infinite set consists of infinite sets and so on. Okay, so axiomatic proof means it should be in a manner of the proof of 1 plus 1 equal to 2 in 378 pages by Russell. No English there, we only want symbols. Take a look. If you understand this is in cardinals, not even natural numbers. All right. So this is the kind of thing I want. Plus, there's a further condition. You cannot assume any result of axiomatic set theory. You can't assume anything about unions or intersections or anything. Whatever you need, you prove from the basic axioms. And I'm offering a prize of 10 lakh rupees for proving 1 plus 1 equal to 2. That's what you have learned in mathematics. To anybody, student or faculty who is able to prove it by tomorrow, who's able to give me a value, just 1 plus 1 equal to 2. So do it. And then you will understand what this thing called entity called a real number is and what this entity called axiomatic set theory is. Please do so. I'm offering 10 lakh rupees. It's a serious offer. Hence, there is a caveat. Don't just put your name on something written by somebody else. You should be able to answer questions. You'll be expected to publicly explain what you claim to have written. All right, by tomorrow. So this is the challenge. This is to explain to you what is so terribly wrong with the existing teaching of mathematics. That's in the whole country, people don't know what 1 plus 1 equal to 2 is. I go to the elite university of the country, JNU, and the professors can't do this. So with the Indian calculus, all these problems, limits, set theory, real numbers, everything disappears. All right, empirical proofs are accepted. No limits are needed. Derivatives only finite difference. What we talked about was khandaja. That's finite difference. All right, and that is the thing that is needed for Aryabhat's method of numerical solution of differential equations. Today also you do finite differences for numerical solutions. You don't use real numbers. You can't use real numbers in a computer because a computer works with floating point numbers. And every problem, you see, you mentioned CDAC, and I was looking after the application development group there, and let me fill up this easier. And every problem that I surveyed all the problems of national importance, space, oil, all sorts of things, scientific applications. Every problem involves the solution of numerical solution of differential equations. Sufficient for all practical applications. That's what we are talking about now, the Indian method. Okay? Needed and sufficient for all major practical applications. Integrals are not needed. What is integral fx dx? It's a solution of y prime equal to fx. It's all differential equations. You don't need it. That is the process of integration. And you teach only elementary integrals. If I give you a non-elementary integral involving elliptic functions, nobody will be able to do it. You can't do it. There is no formula. So, but in this method, you can do everything. Okay, you can also do non-elementary integrals, such as elliptic integrals, which are required for even the first experiment you perform, simple pendulum. Okay, let me just spend a couple of minutes on the sine function that I talked about. So the Oxford English Dictionary says the Latin origin of sine is from sinus, and sinus is a bend, it's a jabe, from the Arabic jabe. All right, that's what the Oxford English Dictionary says for the origin of the word sine. Now, where did this jabe come from? Jabe came from jiva. I'll show you a slope. And jiva comes from ja, which is, we are talking of a chord. And that's related to a circle, not a triangle. Total confusion. because Europeans misunderstood our ganit and we imitated them and we imitated their mistakes. So jiva was changed to jiva in Arabic, but in Arabic there is no va sound because of that. And it was written without nuktas as just a consonantal skeleton, like you write SMS, right? So you will say something, you know, please, you will say PLS. So like that, jiba was written as just j and b, and it was misread as jabe by the ignorant Toledo translators who didn't know any mathematics. They said, what is jabe? It must be jabe, that's the normal word. And we copy it. We copy it and we talk about our greatness without even understanding what we have done and without trying to correct the mistakes that Europeans made. Now, the infinite series for the sine function was first derived in India. All right, so now here you see nihatya chapa vargena chapam tattat phalani cha, and at the end you will see jiva ptyai. So that is the jiva. Okay, I seem to have taken a lot of time. And how does this connect to the infinite series? You can take the translation, it is there in my book. And ultimately, you know, it's an interesting way because the factorial comes out in a very interesting way. So factorial is 2k square plus 2k and so on. And so ultimately you come back to this infinite series, which is familiar to most people. I'm just going through it very fast. I'm sorry, because this can all be done in a course, but not in just one lecture. And it was used for practical things. It was used to derive sign values. So this is how the sign values were derived. They're written in a Sanskrit slok, Shreshtam Nam, Varishtanam, etc. And you'll wonder what has this got to do with sign values. So let me show you how precise those sign values were. These are the 24 values of Aryabhat, which was taken further by Madhav. And as you can see, they were highly accurate sign values. And that is why they were needed for navigation, because you need it for determining latitude, longitude, loxodromes. Won't go into all that. It's a very interesting story in itself, but that is the point. The interesting point right now is how the infinite series was summed. I showed you an infinite series. You can't sum it term by term because that will take an infinite amount of time. But the fact is that the infinite series was summed in India by Decolonizing. Right? So this is the sum in the Aryabhatiya Bhashya. Ganit 17, commentary on Ganit 17. You find this, which is the usual formula for the sum of an infinite series that you learn. Point is, here is the sum of an infinite series. Now, the finite series is very old. Right? Finite geometric series is very old. You find it in Yajurved 17.2. So, for example, 10, 100, 1,000, and so on. You find it even in Egypt in the Eye of Horus fraction. It's there in the architecture. Very interesting. Can't go into it. This thing is ringing. I have taken 45 minutes apparently. So how was it done without real numbers and limits? That's what you need to understand. I think I'm going to take, maybe I have 1.5 hours time, so maybe I'll take 1 hour. It was done by using Brahmagupta's Avyakt Ganit. It's Avyakt Ganit is the Ganit of polynomials. A polynomial, if you write 2x plus 3, it doesn't have a value unless you give a value to x. So therefore, it's unexpressed. And this arithmetic of polynomials was reproduced in Al-Khwarizmi's Algebra wal Muqabla, which later became algebra, which is where you study polynomials in that. But the point is, the polynomial arithmetic is non-Archimedean. It is larger than reals, and reals are the largest Archimedean field. So in terms of formal mathematics, it's non-Archimedean. In a non-Archimedean field, there are no limits. There are no limits, and so there are infinities and infinitesimals, but there are no unique limits. Just as in a smaller field, rational numbers, there are no limits necessarily. There may be limits occasionally, but in non-Archimedean field also, same thing happens. So the simple process is that the formula of a finite sum is extended to the infinite sum, and you give away exactitude. Infinitesimals are discarded. This is on the philosophy of zeroism. And I can't go into further details because further details will require a full course. I can't just explain in 5 minutes. If you think that, I mean, it's not possible. 5 minutes, 1 hour is not possible. So point is, course on calculus without limits has been tried out. First tried out in 2009 in Central University of Tibetan Studies. Right? This was in 2009. That is Mr. Santen, the Vice Chancellor, in Sarnath, and in 2010 it was tried out with 4 groups of students in the University of Science Malaysia. There is a report of it. So why is it taking so long? Right, teaching mathematics with a different philosophy in the University of Science, Malaysia. And similarly, there's a report in part 2 on calculus without limits. So these are both available on the archive. You can check it out. In 2012, it was taught in Tehran, CISSC Tehran. So here's the poster. And here is a group photo of Tehran. And this was taught to a general audience who were not necessarily scientists or engineers. It was also taught in Ambedkar University, Delhi, calculus for social sciences, social scientists. And here's a group photo of that. And that's the Vice Chancellor. I think he's no longer the Vice Chancellor. And as you can see, the students were so happy because they had a big problem. Now they didn't have a problem with the calculus anymore. And it was taught in SDT University. So here is the poster of that. And there's a group photo. These are all science and engineering students. And obviously this was done in a computer lab. It requires a computer lab. So these courses have been tried out. And the immediate advantages are there is conceptual clarity, no unreal real numbers, metaphysics, which nobody understands. Teaches real life applications, example, ballistics with air resistance. It teaches non-elementary integrals omitted from usual calculus courses. So correct theory of simple pendulum using elliptic functions. So you can see this in the tutorial sheet, which was used. So here is the tutorial sheet. Let me look at this. And here you see these are the Jacobian elliptic functions, Snx, Cnx, Dnx. Now, if you have the time, I can show you these functions and how they differ from the sine cosine functions. There is no analog of Dnx. But this is what is required. And this is the system of differential equations that is solved. And they get these Jacobian elliptic functions. So if you have the time, if you are interested, I can show, but I don't know if Zoom will perform and show an executable. So maybe I should just go on, finish it, and I can come back to it. So it also teaches that it is silly to memorize formulae because you have a package called Maxima. I was the first person to get it in India. At that time, it was very expensive, 20,000 pounds. And I thought I had made a deal because it was prohibited. Its export was prohibited by the US Department of Defense. And I got it, but it is now free and open source. And it is very easy to do all this. You can do it on your telephone. You don't need to memorize anything. Okay, so let me come to statistics. I'm running badly out of time. So there's an Indian origin to probability and statistics. So you can take a look at my, I think I give you this, showed you this article already. There's also an article on probability in the Encyclopedia of Non-Western Science, Philosophy, and so on. So the thing is that they arose in India as normal mathematics or ganit, no formalism. Probability relates to the game of dice, and you know that the game of dice is there, not in the Mahabharata, but it is also described, the first account is in the Rig Veda. This is really there in the Rig Veda, right? So it's the Aksha Sukta of the Rig Veda. So I can show you this. This is the Aksha Sukta. And see what they say. Rig Veda says, Somasya Mahajab Tasyam Aksho. Right? There is pleasure like the som in the dice. So there is a very long description of that in the Aksha Sukta. And its translation, if you like, well, I'll just give you, this is the translation given in my book and so on. But you see how the dice attract the gambler. And he goes and loses everything, but he goes on playing. And when he wins, he's so happy as if a son is born. And if he loses, he is dead and so on. Now it's 53 dice. It is 52 weeks in a year plus one joker, because you have intercalary weeks. So this game of dice came from India. At least you have the first account of it long back. You have the account in Mahabharata. You know that Shakuni wins the game by deceit. That's very important that he wins the game by deceit, because you can have deceit only if you have a concept of a fair game, right? And so he had a concept of a fair game or an unbiased game. And then you have the account in the Mahabharata, 1/72, there's a story of Nal and Damayanti. Nal goes up and takes up a job with Rituparna, and Damayanti announces her remarriage. Swayamvar. And when they are going, they're dashing to Vidarbha from Ayodhya, they stop on the way near a vibhitak tree, which is the dice which was used, five-sided fruit, looks like that. Is used in so many Ayurvedic ointments like Tripura. And this was used in the game of dice. So Rituparna shows off his knowledge of Ganit by counting there are 2095 fruits in that tree. How did he do it? So he did it by sampling theory. It isn't just that there's a game of dice and some concept of probability. He did it by sampling theory. All right, sampling theory is how you use, and Rituparna explains this to Null and so on. He wants to check, and he says, I will cut down the tree and check by empirically whether you are right or wrong. And then he gives him the knowledge and explains to him, and they finally go. And of course, Null finally marries Damayanti, and they live happily ever after. Point is, theory of permutations and combinations is also found in many ancient Indian texts from a long time, from Pingal's Chandas Sutra. So you find it in common texts like the Pati Ganit of Sridhar. So this is the formula for permutations and combinations. That's the basis of probability if you have studied it, right? So this is what Sridhar does, and this is the formula as you know, right? But he's giving it differently. He's not using a symbol NCR or NPR. So when these Cochin-based Jesuits stole the calculus, they also stole probability. And well, I think already told you that Indians had trigonometric values which were very accurate. And they had binomial coefficients and Pascal's triangle. So Pingal's commentator Halayud, he talks of Khandameru. And that is Pascal's triangle. That is what Bhaskar too also calls it, Khandameru. Interesting thing is that in 1657, Verma posed a challenge problem. Posed a challenge problem, and it's a solved example in Bhaskar's Ganit. That's direct proof. How do we know it's a solved example? How do we know it is from there? Because the numbers involved in the problem are so very large. Okay, these numbers. And not a single person in Europe was able to solve the problem until Euler did it. Of course, Euler had access to Indian sources. The very large numbers cannot be a coincidence. It's a solved example in Bhaskar's Ganit. So, this is the point. And now the point is, because they stole, like students who copy in an exam, the Europeans didn't understand, and they didn't understand, they still don't understand probability. Please take a look at my lecture that I gave in JNU. And so they turned it into formal math, and then you have probability, Lebesgue integral and Lebesgue measure, all of which it's very hard for most people to understand. Especially for management students who need it for marketing surveys, etc., or for students of social science and humanities who need it for various things. Statistics also needed for AI. Today, everybody wants to do AI. What do? They take Google TensorFlow and run it without understanding. They don't understand the basics of statistics. But it's very, once you understand, if you don't understand, use a thing without understanding, it can result in a major calamity tomorrow. Because you don't know when the program will fail. Statistics needed for finance. So if you see, a lot of people these days, IIT students and science and engineering students are shifting to finance. You can take a look at the video of my JNU talk. Maybe I can show it. I don't know how fast it will come up. Yeah, this doesn't have an ad, fortunately. So this thing is available here. And maybe you can stop that video and see what the link is. So I will skip that. It is available there. The point I'm making is that the failure to understand can result in a huge crash. That is what happened in the subprime crisis. If people didn't understand what the computer programs are based on, they didn't understand the statistics. They said whatever the machine says is right. And so they took large risks and they failed badly. Now let me come to the history philosophy of science. I did an analysis of Macaulay. How did Macaulay impose Western colonial education? He did it using a false history of science. And this analysis is in this book of mine, Ending Academic Imperialism. So you see how we are producing, these are supposed to be like brains, and you produce completely uniform stuff and people are not able to think. So The point is, he did something. Why do we blame him? In fact, he is not to blame because the same education system is found all across the world. We never checked it. Why did we not check it? Why are we refusing to check it today? 73 years after independence. And we keep saying Macaulay did this. What have we done? We are not able to check or do anything. We don't even have a single thing, a single department till now. So I did this in Malaysia. There was a week-long history, philosophy of science workshop. After this analysis, it said we need to teach it. So we developed a new curriculum. And there were people from 3 countries there, from Iran, from India, and from Malaysia. There's a report of it in the Iranian paper. And this developed a new HPS course, and that link is available there online if you take a look at it. This was a link that we developed, and it is developed according to the Malaysian Qualifications Agency, because they have to follow those rules. It's available online. But we did it in a way in which it is not taught in Western universities. Every Western university has a syllabus, has a course on history, philosophy of science. They never mention these things. And we don't want to change it. Because we don't want to invest in it. We don't want to study it. We only want to say we were great, but we don't have anything. We invest in everything, but not in this. Very sad. So this course was first taught in Al-Bukhari University, Malaysia. And you see, these are the students. I took them on a trip to measure the size of the earth, how it was historically done in India, and as described by Al-Biruni. Because the way Khalifa al-Mamun did it, he physically went and measured 1 degree of the arc in the desert. The Indians did it in a much more sophisticated way. So these are the people, they did it, they're very happy. They learned something. The course was very popular, and there's a short video. I don't know if this video will show. Should I play it? Maybe 2 minutes. Are you able to see the video?
Yes, sir.
Claude Alvarez is the interviewer.
Uganda.
I'm from Kyrgyzstan, Central Asia.
Ahmed Zafar from Yemen.
Eritrea, Kyrgyzstan.
Somaliland. From Mali. Close to about 2 months now. 2 months? Yeah. And how do you find it? I find it like very, very informative, because there are so many things I've come to realize that I have never known in my lifetime before.
The purpose of this course was just freeing our minds, telling us that the story that we have been told is maybe not totally true. There might be other sides of history also that has not been told to us.
Yeah, it has touched me, and I feel like I need to dig deep into the part of philosophy and find out. Maybe there is more that is yet to be discovered, and more what Africa has done than what actually it knows.
So I think the course, History and Philosophy of Science, enlightened us to those gaps that couldn't be filled with our education system maybe, and also to acquire knowledge more about it.
He will give you, for example, the evidence, and you can apply it and see it by yourself. So you don't need much efforts to know whether it's true or not true. Actually, the impact was not only in one thing, it was in so many things, in human personality. Like, I cannot say there's one thing changed in my life. Like, so many things changed. If there was a possibility for me to introduce my country, I would do that very much.
He did a lot, and what I can say now, my brains are washed.
Personally, I mean, without any exaggeration, I enjoy this class more than any other classes.
Haju is really one of the most outstanding lecturers I've ever met.
He's perfect.
Very good.
Yeah.
That's a great A. You would give an A or A plus. As a student, you should once in a way assess your professors also.
I would give a star.
So this was the course. As you can see, it was very popular. There's a longer video also. The second part of the course was developed. And that course had emphasis on, it's a long document based on the Malaysian qualifications agencies and so on. So I won't go into all those details. But the emphasis was on philosophy. And this was also taught in Al-Bukhari University. So it's a different set of students. And course was localized. So the idea is that you don't teach the same course in all countries. So as per the original recommendation of the workshop, which we formulated, you should have to localize the thing for different countries to suit different countries. And when I taught this course in Centurion University in 2017, and this is clear from the final question paper. So let's take a look at the final question paper. And let me go first to page 2. So all these questions, why did Arabs and Europeans seek out Indian arithmetic? What were their difficulties in understanding Indian arithmetic? How did Aryabhat calculate his values? Did he use geometry or did he use a numerical approach? How were they so accurate? And what is the evidence for transmission of calculus from India? What's the opportunity? What's the motivation? What's the circumstantial evidence? And if you have some infinite series like the infinite series for square root of 2, what will you do? How will you sum it? All right. And the emphasis is that you must check history using primary sources. See, that's an important aspect of the course, because a whole lot of false history has been systematically created by the church and Western historians. We never checked it. We believed everything for 200 years. Oh, wo bolta hai, wo to sahi hoga, wo to Lord hai, Macaulay. So you have to, the first step is to establish your inferiority. How does the church convert? First says that you are inferior, then says we are superior, then says you imitate us. So if we accept everything, indigenous is inferior, as so many people across the world, not only Indians, so many people across the world have accepted, you are already half converted, that you are inferior. That's the point. To rule over you by making you believe you are inferior. So what's the remedy? How do you check it? So most people, what do? They go to Google, which takes them to Wikipedia. But Wikipedia is an unreliable tertiary source. So they should know the difference between tertiary sources, secondary sources, primary sources, which is what the thing does. That's the first question that is asked. What are secondary, primary, tertiary sources? So they need to check, they need to understand how it is done. All right. And so on. And standard texts are secondary sources which are not reliable. And let's take a case of Euclid. You know, we saw the class 9 text, Euclid's geometry. And I asked, I asked NCERT, what is the primary evidence of Euclid? They are not able to answer. I offered a 2 lakh rupee reward. They cannot answer. So this was done long ago. There's a video on that, my offering the 2 lakh reward. So you can take a look at it. I won't, this in University Science Malaysia, won't go into more details. Take a look, those videos are there. There's a lecture and there's a big thing on decolonizing history. This was done around 2011. So the NCERT has no primary evidence. I have a written document from them. They don't have primary evidence. They say, you read this Western text. Who are you to challenge what is written in Western text? Why do you want evidence? We teach that nonsense. They've been teaching that nonsense for so long. We'll continue teaching that. Not our problem. So the need for philosophy also, let me emphasize, which people don't understand, that a bad philosophy is used to support a change in history. So let's look at question. No, where is my question paper gone? Question paper is gone. I have to get it back. Question to be, why did I close it? I did not intend to close it. Okay, the question is about the Pythagorean proposition. The claim is that we frequently claim it is found in the Shubha Sutra. It's not the Pythagorean theorem. We should know the difference between a theorem and a proposition. And it ignores the Purva Paksha. The counter argument right in our school text. So this is there in our school text. What is it? That Indians didn't do what Pythagoras did. They provided proofs. It's there in our school text, 9th standard school text, the Purva Paksha. So you may have got the statement, but it was no use because you had no deductive proof. That's what our school text says. Is it true or false? It's false. Because Indians did have a proof. So this is the proof of the Pythagorean theorem, which I gave long ago, but it's an empirical proof. You put these two squares one on top of each other, then cut it like this, okay, and then cut it like this, and then you rotate this part like that, and you rotate this part like that, and then you see that the bigger square is equal to the sum of the two smaller squares. It's an empirical, it involves an empirical method, but also uses reasoning. Now, what is wrong? That's a philosophical question in using this. Because empirical methods are accepted as the first means of proof, pratyaksh praman, by every Indian system of philosophy. Reasoning is accepted as the second means of proof. And that is true in science. So what's wrong with it? Why can the government not explain? They'll neither withdraw nor provide evidence, just copy. We are teaching you to imitate because you are in, their aim is to produce slaves, like the colonial government. So how does it become superior? All our math teaching and stat teaching is based on that belief that prohibiting the empirical makes something superior. And that belief derives from a church superstition. That if you have proofs based on axioms and prohibiting facts, they are infallible, like the Pope. Complete nonsense. I mean, anybody who is a math teacher should know that there are so many fallible proofs that people give. I used to get so many of them. How do you say it is infallible? So these are just this. There's another doubt that people have. Oh, math works. See, rockets fly, bridges are there. But what works in math is calculation or ganit. I have to calculate a rocket trajectory. I don't prove. I go to a computer and I calculate. I have to calculate the strength of a bridge. So that is what is done. What is done with the Shulva Sutra? You have to look at the manas. First of all, you should know which one. Everybody keeps saying Badhan, Badhan. You look at the manas Shulva Sutra. What does it say? Ayamam, gunam, vistaram, vistarentu. Samasya vargamulam. Yattat karna tadvido vidu. So you are talking about, first of all, you are talking about a square. Okay, square which has sides A, B and a diagonal D. Karna is the diagonal. All right. So difference. And what you are saying, well, how do you learn it? So, okay, you have right angle triangle, treat that as the hypotenuse. You learn D square equal to A square plus B square. But the Manav Shulva Sutra says something else, Vargamul. So D is equal to root A square plus B square. What is the difference? They are not the same because calculation of square roots was unknown in the West until the 12th century. Forget about Pythagoras. If he ever existed, there is no proof that he existed. Pythagoreans existed, but not Pythagoras. So how did they evaluate the square root? Evaluation of square root, known in Egypt, known in Iraq, not known in the West. So there are many other such differences. It's important to understand that. In fact, most ganit, arithmetic, algebra, trigonometry, calculus, probability, and statistics first went from India to Europe. But we copy them. Think how foolish we are. Whole country. We can't have a course on history, philosophy, or science. We can't have a department. And even in geometry, we need to switch back to Rajju Ganit. So this is my textbook on Rajju Ganit for 9th standard. This is similar to the way Egyptians did geometry. I will not go into that once again. I'm just saying that almost all math you can do by this. So this cannot be covered in a lecture because there's so many details that will require a full course. So conclusions are that teaching math, just let me reiterate, it makes math easy, both calculus and statistics. It enables students to solve harder problems, not covered like elliptic integrals I showed you in the usual courses, and to acquire a solid conceptual grasp of what they are doing. At least they understand what is exponential function, what is sine x, etc., what is the derivative, because finite difference is no problem. What is the integral? They are looking at solutions. And teaching HPS courses is essential to end our half conversion through a sense of inferiority, through false history and bad philosophy. Because if you don't engage with philosophy, you think philosophy is useless, entire teaching system has been changed by saying this philosophy is superior. And the resulting mental slavery to the West. And final word that I will say is that for the students who might be listening, you have to fight. Nobody will free, nobody else will free you from slavery. They are enjoying your slavery. And if you only want to be a slave, you will remain a slave. And the fight for freedom did not end 73 years ago. This fight for your mental freedom requires knowledge, not arms. And so demand knowledge, not merely certificates. And accept knowledge from all sources. I'm not saying reject everything Western, but choose what is best, not just what is best. Thank you very much. Questions?
Excellent, sir. My dear students, any doubts are there? Please get it clarified by Professor C.K. Raju, sir.
Yes, this DN. Yeah.
Students can post in chat box also. Okay. Sir, proceed, sir.
Yeah, this DN Rao here, sir. I was very, I would say, shaking the foundation, so to say. So it's difficult to ask questions.
Exactly, sir.
I would like actually to go back to not just calculus and this thing, but to the number system itself.
Yeah.
I somehow felt that the whole conception of number system as the way it's taught to the school kids in India, that's where perhaps the confusion actually starts for mathematics, right?
No, I think students are able to manage natural numbers. They are able to manage fractions, which are the rational numbers.
Yeah.
The difficulty they have is with real numbers.
Yeah, real numbers, yes. And I mean, really to understand also, the whole, I mean, conceptualize this itself is a problem. And then working with them is also even more problematic.
Yeah.
And your whole thing about empirical proof versus axiomatic proof is a great point.
Sir, we have got Professor Shantamagaru,
yeah.
a 90 years old emeritus professor of physics with us, sir.
Okay.
He has been producing good number of publications in Vedic mathematics, sir.
I see.
Professor Shantamagaru, please open your mic, madam. Professor Shantamagaru.
Good morning, sir.
Good morning.
I am Professor Shantamma, Professor Emeritus.
Yeah.
And Professor Rajgaru was once my teacher, my student, a brilliant student. I had worked on Vedic mathematics.
Okay.
That is developed by Swami that is a recent book on Vedic mathematics.
Yeah.
And that is Jagadguru Shankaracharya of Puri Mutt. So I completed all the theorems and I got them also on the program side. Now you have been mentioning that it is, there's nothing Vedic method, Vedic. Vedic is the thought itself is Vedic. Shall I just give you a simple method of multiplication, 998 into 996. The way in which they have multiplied the Vedic people, they have taken 1000 as the base and the difference between that is 2. First one, the second one is 4. So with the multiplication of 998 to 996, instead of that, they have multiplied only with the differences. That thought is there. They have simplified that. The next one they have used that the cross addition. We have never used it so far as my simple knowledge goes. I have never
may I interrupt
you? Yes.
May
I have never used. Yes.
There are 2 or 3 things here. First thing is, you say Vedic people. How do we look at Vedic people did this? Because if you look at the Vedanga Jyotish, and if you look at everything, they use the method of multiplication we use today because it is arithmetic which went from India to Europe as algorithms based on Al-Khwarizmi's work. All right, that's number 1. So we don't know that Vedic people did it. There is no mention in the Ved, there is no mention in the ancient Indian literature across 3000 years. And the second point is that if you are talking about techniques of mental techniques of arithmetic, this has no great value for science today. If I want to solve a program, if I want to solve a problem, I'm going to use a computer program for it. I'm not likely to do it all mentally. I don't need to do it mentally. So these are the 2 questions that we need to answer. What is the connection to the Ved and what is the practical value in science today?
Yeah, I have only found out that the thought itself is Vedic. It is not Vedic people have thought as in that taking the difference from 1000, that is being multiplied. So they said that the solution is in the problem itself. Search for such similarities, simple bits, and you can get the problem, they have said. So what we have done here is cross addition. I have never used cross addition so far. Cross multiplication I have used in mathematics. So this cross addition is a new thing that they have used. By such cross addition, they have got 998 minus 4, 996 minus 2, they give the same result 994. So a simple result which is just the same by doing such cross addition, which is a different procedure, they have got a simple same value. So that value is given the first preference for the answer 994. The second one, they have multiplied the differences 4 into 2, 8. Then they have thought that how many digits should be there, because in multiplication the total number of digits, if we multiply by this method, by our method, it will have so many digits, placements. So they counted that from 1000, 1 is removed, 3 divisions should be there, therefore 008. So 994 is significantly placed, 008 is calculated. This seems to be really very appealing to the children like students, but it can be done for bigger numbers also. So this thought, I'm only referring to this type of thought, that within the program itself, there are certain similarities, certain dissimilarities, certain expressions which can form the groups of the answer. I'm saying from that point of view, the Vedic mathematics. That's all. I understood that.
Thank you for your comment. I've already made my response. I have nothing new to add except one thing. I had a discussion with this gentleman who is doing Vedic mathematics along with Mr. Batra. This was, I think, in 2016. So the argument that was given was that all knowledge is in the Ved. And therefore, this is Vedic, whether or not it is found in any recension of the Ved, as the book admits. So when you say all knowledge is Vedic, I asked him whether Lokayat, whether you know all the Gnostic schools, like Lokayat, like Buddhists, like Jains, who don't accept the Ved as a means of proof. What about them? Are they also part, is their knowledge also part of the Ved? So one question, there's a whole response. You see, the response is on my website, in my blog, where he asked these questions and I gave detailed answers. So maybe you can take a look at that. And the idea is that current practical value, because these people did invite me to talk, and they agreed that they should not call it Vedic mathematics. I said that solves 80% of the problem. And the remaining 20% of the problem is that how do we use it? Supposing I want to do quantum mechanics or whatever, how exactly am I going to use it? This mental technique of addition and multiplication, in what way will it benefit me? Like I told you, if you do calculus without limits, then things that simple pendulum, problem of a simple pendulum, how it affects quantum mechanics, I can talk about that, but that's a more complex issue. But simple thing like first science experiment that people perform, the simple pendulum, they are taught that it is simple harmonic motion. It is not. Right? So these are some of the things, and then this is the only problems at the level of undergraduates. There are lots of issues at the level of postgraduates and so on, but I don't want to talk about it in this situation. I mean, there are much stuff that I have written, so you can take a look at. Somebody had a question. Somebody had a question in the chat box. What was the question? People need to know applications in specific domains. Oh, Sandeep. All right. The applications are very straightforward, because whenever you are doing calculus, I mean, let's say, what are you thinking of? Let's take the example of shock waves. I'm taking a very concrete example. You see, there's a problem with the calculus, that existing calculus, you cannot differentiate discontinuous functions. College calculus. You can differentiate discontinuous functions if you are working with Schwartz distributions. But the problem is that Schwartz distributions do not allow you to go to the solution of a nonlinear differential equation, which is what most equations of physics are. Now, if we are looking at a situation of fracture, if we are looking at a situation of shock waves, then the equations of physics will not make sense. Aerodynamics, shock waves, if you have, let us say, a supersonic plane and so on, or if you have a rocket, you'll have a shock wave, and therefore the equations will break down there. Now, the way I solved the problem in formal mathematics long ago was by using what are called products of distributions. That involved something called non-standard analysis. But the critical element there was non-Archimedean arithmetic, that you are able to make sense out of infinities and infinitesimals. But in non-standard analysis, these infinities and infinitesimals enter only at an intermediate stage. In the case that we are doing, because we are changing the number system, instead of real numbers, we are using non-Archimedean arithmetic, the Avyak Ganit of Brahmagupta. So we already have, and we have them on a permanent basis. What we are giving up is the notion of exactitude. So the advantages to the theory, which could not be done. You know, I have an example in my book. Let us say shock waves in real media like air, which has viscosity, thermal conductivity, and so on. Or you look at shock waves developing in general relativity. This year's Nobel Prize went to Penrose. What is the singularity? Right? I had a debate with Penrose many years ago, 97. I asked him this question. He had no answer. All that happens is that the calculus breaks down. It doesn't mean that relativity theory breaks down or that a black hole forms and so on. And that's the level of confusion. There was a big quarrel about it in South Africa as well. So the applications are very much there that you can go far beyond what is done with existing calculus. All right. But to explain it is not a trivial task because everybody has learned things in a particular way. And then you have to go to that and then be able to read it and so on. So the equations that I derived for shock waves, which are there now quite some time, and I have not pushed them and nobody has taken them up. So there are distinct advantages to using this method in advancing science. I will be giving a talk on that in Geneva actually. There was a talk I was supposed to have given in Palestine Technical University. So, but it's a technical matter. You can't do it in front of an audience of 1,000 people where most students may not understand what I'm talking about. No, IIT, BHU, one teacher walked out. What are you saying? Discontinuous functions can be differentiated. Of course, I've been differentiating them for the last 40 years. Dirac delta function, the derivative of Heaviside function, which is a discontinuous function. He didn't know. He taught something. He thought that's the absolute thing. So these are difficult things for people to digest. It takes time. So applications are there. We can go through with that very clearly. Extra application. Whatever is done currently is, of course, there much more.
Exactly, sir. So, any more queries, students? If not, I request Professor C.V. Gopinath Garu or beloved registrar, sir, to give concluding remarks.
Thank you, Professor Acharya Garu. We are mesmerized by your talk, sir. C.K. Raju Garu. Wonderful presentation. And many points really, for the first time I'm listening, I'm aware of these points and really useful to the students. As an independent private university, and we will think of, actually we will think of with the higher authorities, if it is possible to introduce this type of courses to our students as a choice-based credit courses like that. So definitely highly useful, sir. And some of the facts surprising to know regarding these mathematical equations and all, which are originated from India and traveled back to India through Western forces, colonized forces. So we are really honored to listen to your talk, sir. And I think most of the students and faculty felt the same. In future, once this pandemic is over, we would like to have your presence in our university, sir, if it is possible. If your time and all possible, we would like to have your presence and address all the faculty and students. And as our Vice President sir already mentioned, we would like to explore the new concepts where we can use this in our courses and curriculum. Thank you very much, sir.
Sir, thank you, sir. Now,
Achal
I
garu.
request to, yes, sir. I request to Srimati Kalapurna Nalla so to propose formal vote of thanks to Professor C.K. Raju garu. Kalapurna madam?
Yes.
Yes, ma'am.
Namaskaram to the August gathering. Colonialism, as defined by you, Professor C.K. Raju, where I had gone through one of your videos, means con all ism or con all people with the help of things which one regards sacred, including math and science. So the colonialism changed the face of the Indian education. And though there is enough of contrived dichotomies, today there is a need to interpret the development of the human in a framework and in a context as a whole. The questions of human development embedded in harmony with the culture will empower us to reiterate on the continuity of the Indian knowledge systems, its present relevance and integration with contemporary human development concerns. Hence, there is a need to repossess the past and revision the future. This is my privilege to be giving a vote of thanks. Centurion University of Technology and Management is humbly honored to have the presence of such a luminary in the world of Indic sciences, Professor C.K. Raju garu, and for delivering such an interesting and gripping session on understanding calculus based on the calculus as it originated in India. I'm sure your passion has ignited a spark in all of us to examine and understand the relevance and contribution of Indic knowledge systems in education. Thank you, sir.
Thank you.
Our sincere thanks to Mr. Prashant Kankanwadi from Vyapam for introducing you, C.K. Raju garu, to us. Thank you, Mr. Prashant.
Thank you, madam. Thank you very much. It's my honor to have this opportunity to introduce sir to university, and we'll take this forward towards the courses, and we'll try to explore more such things in coming months. Thank you very much. Thank you.
Heartfelt gratitude to Professor D.N. Rao, the Vice President of CUTM, and Professor G.S.N. Raju, the Vice Chancellor of CUTM AP Campus, for initiating the idea of having a seminar or this talk on Indic knowledge systems and bringing this concept to the young generation. Thank you so much. A warm thank you to the entire management of the Centurion University of Technology and Management for arranging such an eye-opening session. Thank you, Mr. Narsingha Das, for the technical support for having a virtual conference and also for airing it live on the YouTube. And last but not the least, thank you, dear audience, for your presence, which makes the whole program so encouraging. Thank you.
Thank you very much, sir.
Thank you, madam. Thank you very much.
The program has ended, sir. Very kind of you, Professor C.K. Raju, sir. As told by our beloved registrar, sir, we'll be having your gracious presence once this COVID situation is over. Please visit our campus whenever you feel free, sir. Very kind of you, sir. Namaskar ji.
Namaskar.
Namaskar.
Thank you.